Before transformers, we used RNNs to process text. They read one word at a time from left to right. By the time the model reached the end of a sentence, it had already forgotten what was at the start. This is called the vanishing gradient problem. Gradients shrink as they travel backward through many steps. LSTMs added memory gates to help retain information. But training was still sequential and could not be parallelized. In 2017, 8 researchers at Google Brain published a paper. The paper was called "Attention is All You Need." They proposed a new architecture called the transformer. It removed recurrence completely and replaced it with attention. The transformer processes all words in a sentence at the same time. This parallel processing made training dramatically faster. It became the foundation for BERT, GPT, Claude, Gemini, and LLaMA. Every large language model today is built on this architecture. The transformer has 2 main components called encoder and decoder. The encoder reads the input and builds a deep understanding of it. The decoder takes that understanding and generates the output. Together they were originally designed for language translation tasks. BERT is an encoder-only model trained to understand language. GPT is a decoder-only model trained to generate language. T5 and the original transformer use both encoder and decoder. Knowing which model uses which part is a common interview question. Before any text enters the transformer, it must be tokenized. Tokenization breaks words into smaller units called tokens. The word unhappiness becomes 3 tokens. Unhappiness. The word plane becomes 2 tokens. Playing. Tokenization exists because rare words would explode the vocabulary size. Subword tokenization balances vocabulary size and meaning. GPT uses byte pair encoding to build its token vocabulary. BERT uses WordPiece tokenization, which works similarly. After tokenization, each token is converted into an embedding. An embedding is a vector, which is a list of floating point numbers. A vector with 7, 6, 8 numbers represents 1 token in BERT. A vector with 26 negation numbers represents 1 token in GPT-4. These numbers encode semantic meaning, not random values. King minus man plus woman gives a vector close to queen. Paris minus France plus Italy gives a vector close to Rome. This analogy shows that Embeddings hold real-world meaning. Similar words have vectors that are close together in space. Dissimilar words have vectors that are far apart in space. Distance between vectors is measured using cosine and similarity. Cosine similarity of 1 means identical mean and uno means unrelated. And Blecker are learned during training through back propagation. The model adjusts these numbers after seeing billions of sentences. After training, the vectors become semantically meaningful. This is why pre-trained Impacto transfer well to new tasks. There is one problem with processing all tokens at the same time. If we feed all tokens in parallel, we lose the order of words. The sentence dog bites man and man bites dog have the same tokens, but they have completely opposite meanings due to word order. To solve this, the transformer adds positional encoding to each embedding. Positional encoding is a set of sine and cosine values. It is calculated using the position index of each token in a sequence. Token at position 1 gets 1 pattern, and token at position 2 gets another. The positioner in reads as identical. Sine and cosine functions were chosen because they generalize to longer sequences. The model can handle shoe rims as longer nor seeing, but in training, positional encoding is deterministic, meaning it is not learned by the model. It is always the same for a given position, regardless of the input token.